Hey everybody, this is Math 154 at College of the Sequoias, Trigonometry for everyone else. This is 6.2. For most people at other campuses, it will be Chapter 2. This is on radians. And today we're covering the unit circle and some word problems that are like linear speed and angular speed. First, I wanted to direct you. I mentioned this at the end of the last video. There's this website, calcworkshop.com, and here's the code or the website right here, radians-measure/units-circle/ type that in and you will get the following screen. It'll take you here, and I recommend you scroll down. There's some good stuff. You can read it. It shows everything that we're going to be doing right here in nice typed out form. But it gives a way to memorize the unit circle. I will have handouts on the website in Canvas if you're in my class. Otherwise, they have the blank unit circle worksheet right here. And you can practice it. And I recommend watching this video actually in its entirety. If you do that, you will totally get the fundamentals of radians and degrees and switching back and forth between them and feel comfortable doing it if you work on these things. If you don't, the big thing I want you to see starts at minute 24.
Unit circle again.
Do this and watch it all the way up to about 46 minutes. She's very good, and when I teach it in class, I watch it with you. Every semester I watch it because it's good. She's really good. And so let's get back to our lecture. Let me change what I'm sharing, get back to my work screen. All right. So let's take a look at what we're doing. So 6.2 radians and the unit circle. So I want you to recall that we had sine theta equaled y over r and cosine theta equaled x over r. Now, if we wanted to clear the fractions, we multiply both sides by r, we end up with the following. Y equals r sine theta and x equals r cosine theta. Okay? This is really the basis for all of the values of x and y on the unit circle. And recall on the unit circle, radius equals 1. Okay? Which means we end up with y equals sine theta, x equals cosine theta, and so xy turns into cosine theta, sine theta. Okay? And also this forces s equal r theta to turn into s equals theta. Arc length equals the measure of the angle, which is kind of neat. So if you watch that video, you can actually do that whole unit circle in 5 minutes. Let me show you. I will do it myself. Pause this if you need it up longer. I will give you a live demonstration of how to bust through this circle pretty quickly. So you get your center grid going on and draw a circle going around. And we've got the 30, 60, 90 stuff is like the things on a clock. 1, 2, 3 o'clock, 4 o'clock, 5 o'clock, 6 o'clock, 7 o'clock, 8 o'clock, 9 o'clock, 10 o'clock, 11 o'clock, and 12 o'clock. Okay. And we have the 45-degree marks between the diagonals. Okay. If you like, connect the lines. Okay. So this is my X and this is my Y. And we need to list the degrees going around, the radians going around, and stuff like that. So I'll do the degrees on the inside. This is 0 degrees and it's 360. We've got 30 degrees, 45 degrees, 60 degrees, 90 degrees. Then we add 30, we get 120. We add another 30 on this one is 150. Halfway between those is 135. You're just going to have to memorize the degree ones. This is 180. We've got 210, 240, 270, 300, 330. And then the diagonal one, maybe I'll do the diagonal ones in a different color. Let's make that 45. This is 135. Halfway between 210 and 240 is 225. And halfway between 300 and 330 is 315. Okay. So we start off, we've got 0 with the radians, 0, pi over 2, pi, 3 pi over 2, and this is 2 pi. And recall, this is, we've got pi over 6, pi over 4, pi over 3. When we get to the other side, that you just reflect it across. Everything over here, we're going to have over 3, over 4, over 6. And we just take the denominator and make it one less. It goes down to 2, and so we've got a 2 pi. Take the 4, it goes down to a 3, we've got a 3 pi. Take the 6, it goes down to 5, it's 5 pi. Now we reflect it across this pi, this x-axis. The 6 comes down here, it's down here. So over 6, over 4, over 3. And now here we add 1. So this will be 7 pi over 6, 5 pi over 4, and 4 pi over 3. Over here, the way I remember these, I reflect them again. Either you can reflect across the y-axis, so I'll have a 3 here, or you can reflect across the x-axis. So I've got over 3 here, over 4 here, and over 6 here. The way I remember it is double it and subtract 1. She says it a little bit differently. She talks about 7-Eleven, everyone loves a Slurpee. Double 3 is 6, subtract 1 is 5, 5 pi over 3. Double 4 is 8, subtract 1 is 7, 7 pi. Double 6 is 12, subtract 1 is 11, 11 pi. Okay? And we know these values out here, 1, 0, 0, 1, negative 1, 0, 0, negative 1. And finally, remember, we've got cosine theta, sine theta. And the way I remember it, sine theta for 30 degrees is 1/2. And that makes the other one root 3 over 2. The diagonals have the same, root 2 over 2, root 2 over 2. And for 60 degrees, it switches from the 30 degrees, 1/2 and root 3 over 2. Now, I'm just going to reflect them over this y-axis. And when I do, the x becomes negative. So I'm going to have 1/2 and root 3 over 2 over here, but the x is negative. I'll reflect that one over. The x is negative. And I'll reflect that one over, and the x is negative. Oop, yeah. And now I'll reflect across the x-axis, and now both of them are negative. Negative root 3 over 2 and 1/2. This one hits this one. This one, the diagonal is the root 2's. And this one is -1/2 and negative square root of 3 over 2. Finally, down here, I reflect this one and treat the y as negative. So if this comes down, I've got 1/2 negative root 3 over 2, root 2 over 2, negative root 2 over 2, and finally root 3 over 2, negative 1/2. And I've completed the unit circle. It took me 6 minutes, but I was slowing down to talk about what I was doing. Okay? This is doable in 5 minutes if you practice it. And it's not a lot of memorization. You need to memorize. Let's see how I can cover this up with envelopes. You need to memorize that quadrant right there. The degrees as well. The degrees as well help. But doing the radians is just adding and subtracting. Simple. Simple stuff. And these just reflect across and change signs. All right. So it's doable by hand in 5 minutes, and I recommend you do. Do this until you can get it down in 5 minutes. I recommend practicing it. Okay. Liquid refreshment. Okay, so as a reminder, the reference angle theta hat, it's the smallest angle to the x-axis. It always goes to the x-axis. Never the y-axis. That's the mistake some people make. It's a common mistake. On the unit circle, S equals theta. So the reference angle is also called the reference arc. And this is the measure of the arc that is shortest to the x-axis. Remember, it's going around the circumference, so it makes it shorter. That's theta. This is S. And this is theta hat. So let me give you some to practice. If you have your handout, you can use it if you filled it out. Let's take a look at doing a few of these. What is cosine of pi over 3? Let me just put some up. Sine of 7 pi over 4. We've got cosine of 5 pi over 6. Sine of 2 pi over 3. What else do you want to do? Let's do a couple more. E and F. Let's do sine of, let's go 11 pi over 6. And let's do tangent of 11 pi over 6. Ooh, let's kick it up a notch. So if it helps, you can shift to going to degrees, but you should be able to do this in your head after practicing this a while. You eventually want to get to the point where you're not looking at a chart, because that'll make it so you can go do test problems and stuff like that with relative quickness. This stuff is going to show up a lot in calculus. It's not going away, I promise you. So cosine pi over 3, that's the 60-degree angle. Cosine there is 1/2. Remember, cosine is the x value. Sine is our y value. 7 pi over 4 is in quadrant 4. It's the diagonal, which makes it root 2 over 2. And since it's in quadrant 4, it's negative. Cosine of 5 pi over 6 is, it's in quadrant 2. This 5 is less than the 6, so it's in quadrant 2. Cosine is negative there. 5 pi over 6 has a reference angle of the pi over 6, which is the 30-degree one, which is the root 3 over 2. Sine of 2 pi over 3, we're also in the second quadrant. Sine is positive here. And that is at the 60-degree reference angle. Sine there is root 3 over 2. 11 pi over 6 puts us in quadrant 4. The reference angle is the pi over 6, or 30 degrees. Sine there is 1/2, and in quadrant 4, it's negative. How could I go about doing tangent? I snuck this in. Just being sneaky. I didn't show you that on the unit circle. Well, remember, tangent theta is sine theta over cosine theta. And we have the sine theta. So we've got negative 1/2 on top. What's cosine theta there? When it goes the opposite of the 1/2 is the root 3 over 2. So we can multiply top and bottom by 2 over root 3, 2 over root 3, clears the bottom, 2's cancel. I get negative 1 over root 3, and when we rationalize it, we got negative root 3 over 3. All right? Sorry, I'm getting moisture on my desk. Got to get a coaster. All right. So we talked about bearing in one of the recent sections. I wanted to talk to you a little bit more about that. All of navigation uses trigonometry. Trigonometry. Ocean ships or boats, they measure distances using nautical miles. Nautical means relating to the sea. For a nautical mile, one nautical mile, this is how it's defined. It's the arc length on the Earth when theta equals not 1 degree, but 1 minute, which is 1/60th of a degree. This distance with using S equals R theta and the R we had before, this is approximately 1,852 meters, or as you know it, about 1.15 miles. So it's a little bit longer than a regular mile. And when they do speed in the ocean, or speed for ships, speed for watercraft, there we go, that's even better, is measured in knots. Like tying a knot, same spelling, knots. And knots are nautical miles per hour. So it's similar to what we know it as, miles per hour. That's how it's done. That's just info for you. To fill out your ocean knowledge. Believe it or not, the oceanography, if you go into oceanography, there's a lot of mathematics in it because it's a fluid, and fluid dynamics is all the motion of liquid and gases can be covered with mathematics. That was what I majored in grad school. Let's go on. Let's talk about speeds. We've got linear speed and angular speed. So for linear, speed or velocity equals distance over time. Velocity adds direction. Speed is the number part, and if you're like driving north, that's a direction. Now you've got a velocity. And often this is abbreviated V equals D over T. Velocity equals distance over time. We don't use S, that's arc length. And that's linear speed. I'm going to keep that up there because we're going to reference that in our next part. Angular speed, how angular speeds works. If we're on a circle, if we are going around the edge of a circle, like driving around the earth or taking a boat around the earth, distance is actually arc length. So we've got V equals D over T, but D is S. And we know the equation for arc length is R theta over T. Now, frequently, they write it like this. B equals R times theta over T. And they do R omega. It's like the letter W, but really rounded. It's the Greek letter omega. And this is angle measure over time. Okay. And that's called angular speed. So this is angular speed. How quickly we go through an angle over time is omega, and that's our angular speed. And this is in radians. S was in radians, so angular speed is in radians. Radians per time. Okay. So let's do some problems. First example. Point P lies on a circle of radius equaling 16 meters. And it's rotating at an angular speed $16 that is like a carousel. Like the horses, you ride on the horse and there's a pole and it goes up and down. They have it at fairs and stuff for kids. It's rotating at an angular speed of pi/4 radians per second. That's our given information. What we're going to do, we're going to do the following. Find the angle generated by P after 8 seconds. Find the distance P travels in 8 seconds. Find the linear speed. And I got one more. Oh, no, that's it. Okay. So, A. That's our task. Let me pause and let you write it down. Make sure you're caught up and ready to go. All right, so the angle generated, finding the angle generated, we're looking for theta. What is theta? What equations do we have? We have the following equations. We have B equals D over T, which is S over T, which is R theta over T, which is R omega, and omega equals theta over T. What's given to us? Given, this is true for all of them, all the questions. R is 16 meters. Rotating at an angular speed of pi/4 radians per second is omega. Pi/4 radians per second. The second matters. If it was in minutes, we'd have to convert to seconds because the question's in seconds. And we have T for part A, T equals 8 seconds. So we've got R, omega, and T, and we're looking for theta. The equation that works really well is this one. So omega equals theta over T. And let's plug in what we have. Pi/4 equals theta over 8. And we solve for theta, multiply both sides by 8. And we get theta equals 2 pi, which makes it 1 full revolution. Is that a fast moving carousel, 8 seconds to go around? That seems pretty quick. B. Find the distance P travels in 8 seconds. So P is on the edge of the circle and it's going around. P's distance is an arc length. So we're looking for S. And when T equals 8 seconds, theta equals 2 pi. And so we have, well, what's the equation for S? S equals R theta. We have R, we have theta. Not bad. 16 meters times 2 pi is 32 pi meters. And what is that? 32 times pi, because 32 pi meters means nothing to me. It's about 100.5 meters. I know I'm ignoring significant digits right now. I'd rather show you the numbers I get so that when you do it, you match. Finally, C, find the distance P travels in 8 seconds. Well, now we're talking about a distance. This is a linear thing. So now we're looking for linear distance. This is D. Oh no, find the linear speed. Find linear speed. That was V equals D over T. And we know D is S. So we've got 32 pi meters in 8 seconds, which gives us 4 pi meters per second. And if you want to calculate that out, go right ahead. About 12 something. 12 point something. Maybe 13. Okay. Ready for another one? So this is on, let's talk about another round thing that we're comfortable with. That's got writing on it. Let's get rid of that page. Bicycle wheels. So let's look at the angular speed of a bicycle wheel. Bicycle wheel. So we've got a 10-speed bike. Has a large gear. Connected to a small gear by a chain. And I'll draw a picture in a second. The large gear has a radius of 6 inches. The small gear has a radius of 4. A cyclist, the person riding the bike, pedals at 60 revolutions per second, or per minute. Per second, oh my gosh. Their leg would be so fat, he'd be like Roadrunner. A cyclist pedals at 60 revolutions per minute. How far does he travel in 1 minute? Okay, so that's the question. The way it works is there's a big gear and there's a smaller gear. And the pedals are on this one, the big gear. And there's a chain that goes around both. And the little gear is on the tire. Okay. The idea behind it is as you pedal this one, the chain moves a lot on this one, but this one's got a smaller radius, so it's got to move it faster. This gear has to move faster than you're pedaling. So the tire is going faster than you're rotating the big gear. It should be more than 60 revolutions per minute for the tire because that gear is going faster. That's the idea right here. So let's see. I don't want to do this. Well, we've got 60 revolutions per minute. That's what we're starting with. Let's see, red. Let's go red. We've got 60 revolutions in 1 minute. And so what this is, that's the amount of times the tire is turning. Let's find omega. So 1 revolution is 2 pi radians. So we have 120 pi radians per minute. Okay? That's our omega. If we wanted to convert it to seconds, we would multiply by 1 minute over 60 seconds. The 60 seconds or the minutes cancel out, and we would get 2 pi radians per second. And we knew that. He's doing 60 revolutions per minute. He's doing 1 revolution per second. 1 revolution is 2 pi. Okay? So now how quickly, the question is, let's see, how do I want to phrase this? We need to know how fast the smaller gear is spinning, right? The smaller gear tells us how quickly the tire is going. I don't think I give you a radius of the tire. We'll get to that. We need the radius of the tire to tell you how far the bike went. Let's say the tire is 2 meters radius, or 2 feet. We're doing in tire has a 2 foot radius. Okay, we're gonna need to know that the tire that's attached to the little gear. So this is the omega for the large gear. Okay. Let's see its speed. How quickly is it going? So V equals R omega. We have the radius of the big gear. I'll call it RB and omega B for the big gear is we've got 6 inches, and we're going to multiply it by 120 pi radians per minute. And that gives us 720 pi inches per minute. That's how quickly the chain is moving. Okay, so we're pedaling the big gear. The chain's attached to it. The chain's got to be going that distance, which means the chain's got to be going that distance on the little gear. Okay, so then we can figure out, well, we've got 720 pi inches per minute for the big gear, or for the speed. That has to equal R omega for the small gear. It's got to be the same. And we know the small gear is 4 inches times omega s. And if we divide by 4, we get omega s equals 4 inches. The inches cancel. 720 pi, I'll write it down, times 1 minute times 4 inches. The inches cancel. What is 720 divided by 4? 180 equals 180 pi radians per minute. So that's the angular speed of the small gear. And it's attached to the tire, which means it's the angular speed of the tire. Okay. And so what can we do now? Now we know the speed that the tire is turning at. We know its radius. We can find out the distance it goes. Right? How do we do that? We're looking for the arc length. The arc length is the outside of the tire. How far is the outside of the tire moving? S equals r theta. R is 2 feet. Theta is 180 pi radians per minute, or omega is. Oh, I don't want omega. I want theta. But we're doing it in 1 minute, so we've got 180 pi radians per minute. We're traveling for 1 minute. The minutes cancel. Theta is 180 pi. That's how far it goes in 1 minute, because that was the speed. So 2 feet times 180 pi. S equals 360 pi feet in 1 minute. And what is that? It's about 1131. All right. That sort of wraps up 6.2. In 6.3, and I want to say 6.4, we're doing graphing. So the rest of 6.3 is, the rest of chapter 6 is kind of graphing. We go ahead and get these practiced. Try to get good with these angles, these radians, their sine and cosine values. Try to get those memorized. I tell you what, flashcards do a great thing, but if you memorize that unit circle and you can write it down in 5 minutes, you actually will have it generally memorized. I flashcarded it when I was a student. Whatever works for you, it's something you should have memorized. You do not want to be the putz that's grabbing a calculator to figure out some stuff in your calculus class when everyone else has it memorized. Don't be that guy or girl. Don't be that student. Peace. I'll catch you on the flip side.